Thank you, Uncle Tom, for the introduction and opening the session. Assalamu alaikum and good afternoon, good evening, attendees. My name is Tokir Ahmed, and this is the Knowledge Trailblazer Fireside Chat in collaboration with the SciC Academy. Thank you for connecting with us today. So these talks and discussions are aimed at stimulating debate and discussions on civil engineering, innovation and smart technologies, matters of mutual importance to civil engineering and the state of our industry. We have a range of topics that we have lined up for this year and going forward. So keep your eyes peeled as and when SciC sends out the different invites and notices. We are looking to host these events on the second Tuesday of every month, same time, same place. And we will typically have presenters who will give us a
presentation. Thursday, not a Tuesday.
Thursdays. Oh, yes. Apologies. Thank you for the correction. It's been a long week. So yes, so the format, colleagues, is typically a presenter giving us a presentation and a panel of speakers who will then engage in a discussion following the presentation. So that's a typical format that we've used thus far and will then maintain going forward. So then for yourself as the audience, we encourage you to participate, and your participation is via dropping in your comments and questions in the chat box, and from which we will then pick up, your comments and discussion. From our last session, you would find that we had quite a long list of questions. We unfortunately didn't get through to all of them, but don't be despondent. Put down your questions. What we had done is that we had then sent a list of the questions to the presenter, and the last presenter, Prof. Lewis, gave his feedback, and then that we shared with everyone. So if your question does not get answered today, it will be answered. We will then send the list to the presenters, and they'll come back to you with a response, and we will then circulate that to everyone on the call today. So coming back to today's topic, colleagues. So today we'll be looking at the opportunities for civil engineers within the green solar industry. And this session is quite relevant for us these days because now we need to start looking at sustainable solutions and sustainable development. And as you can see, thus far this year, we've had quite a good few storm events. Cape Town got flooded. The port of PE or Port Elizabeth, apologies for that, Gqeberha, also got flooded. The N2, for as long as I've lived this side here, I only remembered once, in 2011 when the sea overtopped the dollars and washed onto the N2. And so far this year, it's happened 3 times in a couple of months. You've got Durban that's being flooded out. So I think in terms of sustainability, something needs to change. As you can see, we are seeing the impacts and effects of adverse weathers. For example's sake, Durban had tornadoes. One wouldn't have expected that for Durban. You only know of the US with tornadoes, but things are happening and things need to change. And it starts with discussions like these, like this today, that we can make that impact and make that change. So coming back to solar, so just a few notes that I picked up, which I'll use as introduction. So as you would know, when it comes to solar within Africa now, South Africa is the leader within solar energy. And some of the stats indicate that from now until 2029, there's an estimated potential of 7.86 or 8 gigawatts, install capacity that we can, achieve. And that is excluding whatever you might find on the residential installation. So that number can be obviously much more higher. The South African PV market is also expected to grow at a compound annual growth rate of 10.56% per annum. So that's what we can expect for the South African environment. And then coming back to the civil engineer, where the civil engineer becomes very important is in terms of planning and development of the physical infrastructure and the solar installation, looking at the ground conditions and structural elements in integrity. There's also the project management element that you find that civil engineers would then be involved in, and also looking at innovative solutions when it comes to the crucial development of solar infrastructure. That's high level, and again, not to steal the thunder of our presenters, but they'll do more justice than what I'm doing. So what we have, or who we have on call today as our presenters is, I hope I pronounced the name correctly, Antje and
Very
Dr.
correct.
Klaus. Yes, so I did a bit of practice before I can just make sure that I pronounce the name correctly.
Yeah.
We do have also Prof. De Kock from the South African Institute of Electrical Engineers. We were hoping to get a colleague in from the South African Institute of Mechanical Engineers. And as you would know, the field of solar does not only deal with electrical and mechanical, but also civil engineers. So we tried to, make it quite broad, so all the different disciplines are then covered. So yeah, I think then from our side, we'll then ask our presenters to present or just to introduce themselves as they come through. And from there, then we'll then continue with the picture from that point of view. So I think from my side, Anja, I think if you can just introduce yourself and Dr. Klaus, and then I'll hand it over to you to then continue with the presentation. Thank you.
Okay, thank you. Thank you. So you already brought a lot of points up, which I want to bring up in the presentation. And Matthias and I, we are actually civil engineers, and I have been working now for more than 10 years in South Africa, and it's the time to really bring the civils on board. And so I thought the market is big enough, it's growing, there's a lot of potential, a lot of work. And so we have a little presentation about ourselves even in the presentation. So I actually could start right away with the presentation if you would not mind.
Please go ahead. Thank you.
Okay, so let me do.
Your screen's frozen on your side, Anje.
You can't see the presentation, huh?
No,
so
not yet.
let me do it one more time. Is it not now?
Yes, we can
it
see it.
says
Yeah,
sharing. Okay.
we can see it. Thank you.
Good. Okay, just wanted. Okay, good. So yeah, that's the topic of the presentation of today. That's the opportunities for civil engineers in their PV landscape. Let me do something that I do not look weird. Let me try to get this on my screen. Okay, cool. Good. Yeah, so I want to say a little bit about our academy. I mean, I saw that you also like to use the event to promote the association. And then I want to speak about solar PV systems, types of components, give a little like a rough input, and also speak a bit about the global market and the market in South Africa. And then also bring up the points in the construction of a small scale embedded generation PV system. So who is involved, and electrical engineers, civil engineers. And then I will hand over to Dr. Matthias Klaus because I always say, I said I studied civil engineering, but I'm really in the management and in a training field since ever. But he is the one really on site at the big utility size PV systems. So that's me. So I'm studied civil engineering in Germany. So it's a diploma, how we call it, but it's equal to a Master's of Science. Since 2007, I'm active member of the board of the German Solar Energy Society, and also of its Thuringian section, which is a federal state in Germany. And I'm the co-founder and CEO of Green Solar Academy, a training academy for PV installers and professionals. So we offer short courses, which also some of them are even coming with CPD points. I'm also in the board of SAPVIA, of the South African PV Industry Association, and I decided to be active in the association to give all the training academies a voice, and also to be a representative of the PV installers, because a lot of the members of that associations are the big players, so the big EPCs, but also all the manufacturers. And yeah, I have over 25 years experience in project management, training development, in the field of environmental engineering and renewable energy. So this is where we are. So our core business happens in South Africa. So the company is placed in Johannesburg, Gauteng. However, we are also active in a few of other African countries. And we have presently 13 academies, and we trained over 8,500 engineers, electricians, technicians on the continent, and I would say about 90% in South Africa. So our core business, as I said, are the short courses for professionals, but we also are active offering training for the youth. We also have a little online e-learning program, and we also consult in training projects. But so what we stand for is training in photovoltaic. That's the last slide of the intro. So I mean, we offer basic courses, and some of the basic courses are also SAE accredited, but we also offer advanced courses for commercial PV design, financing of PV system, compliance for PV system, and we also look for accreditations, international accreditations like the one from the Solar Energy Society, German Solar Energy Society, but also from QCTO, from SAE, from EXA, so and from SAPVIA, the PV Industry Association. So, what is solar? We have different systems. I mean, so what we see lately, or what is very big, the market of commercial systems. The CNI sector in South Africa is really where the music plays right now. However, the residential market so developed very nicely in the last years, and I also will have some detailed information on that. But we also have the utility scale PV systems, so the big ones, or the REIPP ones in South Africa, but also the B2B ones for the commercial sector. And we also have off-grid systems, so systems for rural areas, so which are not connected to the grid. So in general, we say we can distinguish PV systems based on the size of the system. And this is what we just saw a bit just now. So, I mean, like we have pico microsystems. So maybe some of you have a charger, a solar charger, or a solar torch. So the very small little gadgets. Then we have solar home systems. So like the ones, so for instance, which could be used nicely in little residential areas, or residential and commercial, and the residential and commercial sector. And this is a bit unique. So this is what we call in South Africa small scale embedded generation. So all what is embedded into the national grid, doesn't matter if it's residential or commercial, we call it SSEG. Another size is mini grids. So that's when we go to villages, so that we fuel complete villages based on a solar system, which is then very often combined with another source of electricity, and the big utility size PV systems. And based on the use, so we have in general, we say we have grid-tied systems or we have off-grid systems. So based on the use, so the grid-tied systems. So in Europe, very often people have them to save costs. So that thinking process starts now also in South Africa. But in South Africa, the people think about PV as a load shedding cure. The big investors also think about generation of incomes, or the off-grid systems. And I think this graph shows a little bit, so that we are bringing in South Africa a very special market in the game, because if you see like the international solar industry, so we usually distinguish between pure grid-tied systems and off-grid systems. But because of our unique situation with load shedding, so backup systems, so systems which are connected to the grid, but still are able to operate when the grid is not in operation. So this is what we call backup systems, and this is actually it's the dominant. So industry as the dominant systems in South Africa, because I mean that's the beauty of solar in South Africa, so that when you have a solar system with a battery backup, so that you then are able to have it, or then you have access to electricity even during load shedding. So, okay. This is again another graph to actually show the same. So I said, so for the grid-tied systems, so that's how we also started. So when we started with our trainings in 2011 in South Africa, all our courses were focused on grid-tied solar systems. So just the solar modules, the inverter connected to the grid, and one could use it to reduce the electricity bill. So usually no storage are involved. And so you do not have power during power failure or load shedding. And this is why actually since 2017, so in August 2017, so we just changed the whole concept. So when well, not the first, so when one of the load shedding periods started, and so we changed the whole training material to focus on backup system. And this is, as I said, where the market plays. And we still have the modules and the inverter, but we have the batteries, and we need special inverters which are able to work also during power failures. And here we combine, as I said, so the grid-tied and the off-grid world. So this is a picture actually from the city of Cape Town, which shows us what is all involved in an SSEG system. So we have our solar modules on the roof. We have a inverter which converts the electricity, the DC electricity which we get from the solar modules into AC electricity, and we have batteries to store the electricity to enable us to also have access to the solar electricity during load shedding. We also are able to export electricity to the grid. I mean, in general, it's good that we are allowed to connect our systems to the grid in South Africa, but so far still what you get when you export your extra electricity to the grid, so the payment you get as an owner of a system, it's very small, so it's almost neglectable. But anyhow, it's good that we have the possibility and that we are allowed to connect the systems to the grid, even so not all of the municipalities are as advanced and as Cape Town with the registration process. So where do we stay globally? Yeah, this is where the music plays. It's China. So China is not only the biggest producer of solar modules and inverters, China is also the biggest producer of solar electricity. So, and in the last years, China overtook the European countries. So most of the modules, actually almost all modules are produced there, but also a lot of the systems are installed there. So followed by Europe, and a bit later I will have a irradiation map where you see where are the best regions to harvest solar energy. And this is not really Europe. So, but thanks to Europe, we are now able, so with all the research which was done and all the investments, so solar is very competitive now. And if you see, I mean, South Africa is relevant. So South Africa is actually number 10 of the producers of solar electricity. But still, I mean, Africa is a very big continent and we have a lot of solar energy, but we hardly use it. And so, I'm quite confident that this will change soon. Yeah, if you see the development, actually, you see that so in the last actually 15 years, solar really started to become relevant as electricity producer, and also in the last 2-3 years, it really the speed really increased with the installation. However, the MEA region is hardly seen on the graph here. So, but we see that it starts, and most of the installed capacity on the continent, it's installed in South Africa. What is interesting, I think, for us as civil engineers is, what solar systems are installed, because the involvement of civil engineers in the installation or the civil engineering in installation, planning and installation of solar systems is different for rooftop system and utility size systems. But we can see it's almost 50-50. And in South Africa, also the part of utility or CNI installations is taking up a lot. And this is a prediction. So, I mean, as you could see, I worked my whole professional life in renewable energy and solar. And I really believe that solar is the right electricity source. And if you see where we stay now, so 2020, we had still 62% of the electricity production all over the world, so came from fossil fuels, but actually more than 1/3 actually already from renewable energies. And the predictions are that 2050 we only will use 21% fossil fuels and 80% renewables, and actually solar will be on the forefront. So 56% of solar. And if you see what happened in the last 10 years, for instance, in Germany, so solar and wind are really the dominant renewable energy sources. So, as I said, for South Africa, this is the global. It's not an irradiation map. It's actually the world solar photovoltaic power potential. And if you remember what we saw, like, I mean, China has a lot of very high potential areas, but Europe, where the solar journey started, actually is not very privileged with solar energy. But the north of Africa, south of Africa, and Latin America, those are the regions so where we have the biggest power potential. And for us in South Africa, this is especially the Northern Cape, but also in the other provinces. Okay, Durban is not so privileged, or KZN, because we have a lot of rain, but still, if you see where the systems are installed, so it's still, if you compare the colors from the worst areas from South Africa with Europe, so there's still a lot, a lot more of energy to harvest. So South Africa, so we do not have like proper statistics, how many systems were installed, so what is the correct share of solar electricity produced, especially as most of the systems are not officially registered. So the Western Cape, Cape Town, they really pushed everybody to register the system, and we have proper correct figures from the city of Cape Town. However, the SAPVIA, the Solar PV Industry Association, they have on their website a little overview of the installed capacity. And how did they collect the data? So they worked together with two companies, GeoTerra and PrimeSort, and evaluated satellite images. So they just had a look on the one hand side, so what was already installed, but also where are roofs, where are areas which we can use for solar. And this is how they collected the figures. And so they did that the first time, or the big evaluation actually, in Q1 2023. And this is where we now we have about 12 gigawatt installed, gigawatt peak in South Africa, which brings us to makes us number 10 on the continent. But if you imagine that a country like Germany, so installed only last year 14 gigawatt, so you see that there's a lot of potential in the market in South Africa. So, and here you see that picture or that data they used to evaluate the where solar is installed, and you can see if you compare that with the picture where we have the most sun in the Northern Cape, so there's still a lot more potential.
Hi, Antje, you are paused.
So here we see that, and this is especially
sorry,
interesting.
Antje, we lost the last say about 10, 20 seconds. I think you froze a bit.
Oh, my goodness. Okay, am I back?
Yes, it was after you told us about the Northern Cape potential, and then you paused from there. Yeah.
Okay. Oh my goodness, I'm in the Berlin office today. I'm in Germany this week.
Perhaps maybe if you put the camera off, maybe it might just save on the bandwidth. And maybe let's try that maybe. Yeah, thanks.
Okay, good. Thank you. Okay, so I said that here on that here we see such an image they used for the evaluation, and you see that here we see also that especially in the city of Cape Town, a lot of installations are done, and so it's actually all the standards and regulations we have for solar actually are based on what was developed in Cape Town. And this is a very interesting slide. The city of Tshwane actually has actually more installations than the city of Cape Town. But if you speak with the people from the city of Tshwane, so hardly any system is registered. And this is, and also in Joburg, it's quite difficult to get the registrations through the city. In Cape Town, I'm pretty sure that what the evaluation results that they really fit to what also is in the statistics of the city. And so also the growth rate, so almost 40% of growth rate from 22 to 23 for Cape Town. Here we see what is in South Africa, the amount of commercial systems and residential systems. And here you also see, so that's actually what we also saw this year in the developments, that most of the systems are on the bigger capacity, installed capacity is on the residential, in the residential area. Okay, the total, and here you see that the total capacity in the country, so Gauteng has the most installation, followed by the Western Capes, and all the other provinces have still a lot of capacity. There's still a lot of work to do, and especially also in the Northern Cape, where we have ideal conditions. So not a lot of installations were made so far. Okay, sorry. Here we see the future actually. So how they evaluated the areas and how they classified them. Where we can install more systems, and here is the actually the embedded generation network impact. So the potential of embedded generation in the different provinces, and so Savia actually evaluated it based on kilowatt hour per kilowatt peak ratio. So where we get the most energy out of installed systems. And here we are definitely leading in the Gauteng area, followed by Western Cape and KZN, or what I said at the beginning. Good. Coming to what was said before, so South Africa is really, the PV market in South Africa is an electrical engineering market. But if you look what is involved, and if you look what happens in the world in the PV sector, so starting with the planning, so there's a lot of structural engineering involved, site survey, system designs, all work what we usually do as civil engineers. When you come to the installation, so there usually the trades involved are not only electricians. So again, we have roofers, we have civil engineers, we have PV installers. So the whole component with working at heights. So what is usually not like typical for the electricians, but of course we need the electricians, especially to get the COC for the system and to connect our solar system to the grid. But all in all, the installation of the PV system is actually both civil and electrical engineering. And for operation and maintenance, we need engineers that can be civil engineers, that can be electrical engineers, but we also need workforce to clean and maintain the systems. If you see, I mean, this is a slide actually from Subvia, and this is how Subvia sees the PV market, the South African PV Industry Association. And you see that the acts are actually the electrical industry. So they just start with PV is electrical industry, and this falls under Department of Employment and Labor. The relevant act for most of the work we do is the Occupational Health and Safety Act and the Electrical Installation Regulation. The standards we have, so there is a SANS standard, but this is, so comes in the next slide. So everybody knows the SANS 10142, but this SANS regulation is still actually it's very old, and we work based on regulations which were written before solar became part of the electrical production landscape of South Africa. And what is regulated here is the code addresses that the issue of surge protection, embedded generation, lightning protection, all the electrical things. So they also refer to international standards, but so the international standards go over that electrical part. So what nobody knows in the PV industry, or only a few people, and so this slides actually I got from K2, which is one of the mounting manufacturers, and they deal with the problems based on wrong or poor installations. So, and they try to stress the fact that the SANS 10160 is the relevant SANS for structural design, which we actually need when we plan PV systems. And yeah, so there's a nice article which was recently published in the Engineering News about what homeowners should know before investing in solar. And this is that actually, according to the National Building Regulation, it is compulsory for a homeowner of building to appoint a civil engineer to plan, design, and supervise and certify any alterations and additions to any structural of fire system according to Energy Professional Act. So, I mean, it is important to include civil engineers, and I think it's the time that the civil engineers come on board. Because if they don't come on board, this happens, and I don't know how many, I don't want to know actually how many solar systems were blown away yesterday in the big storms in Cape Town. So, I mean, roofs often can't support the additional weight of PV panels. It's not a lot, but so, I mean, we know how our roofs are constructed, and they are just strong enough to carry the roofing, but often not to carry additional PV modules. And wind and sometimes also snow factors are often neglected, but especially the wind in the coastal areas, and structural engineering with PV expertise would be really an added value for the industry. And now I want to hand over to Matthias to give us a little bit of an insight into the utility size PV market.
Okay. Are you showing my presentation or should I do that?
Actually, I'm sharing it if you would not mind.
Yeah, then do that. Yes, my name is Matthias. I'm a civil engineer and I've been working in the solar industry since 2006 or 2007. I don't remember exactly. We started with small scale plants like 3 kilowatts, 5 kilowatts, 10 kilowatts. And then we switched over into the utility scale construction site management, which I'm doing since 2012. And in this relation, we founded a company. We are 4 guys in the G2KV. We are working together, and now we are doing a large-scale project here in Germany. What we are doing, mainly, we are all civil engineers, or no, let's say we have 3 civil engineers and 1 electrical engineer. As Angie said, it's always a mixture of both professions. This is a little bit of our website. We have a reference, or we have a lot of reference projects from the last 15 years. If you are interested, you can have a look. We did some explanations to every project. Yeah, please, next slide, Anja. This is one image of an English site. We have been working in many parts of the world. Some years in the UK, because the UK market was a quite emerging one. Then it collapsed. Then we switched over to Germany. Then we worked in Australia, Vietnam, and whatever. So here you might see the PV sites include a lot of civil engineering. So that starts from road construction. That might not be a necessity in South Africa, but here in Europe, we have to construct roads because we have to bring in a lot of lorries with materials, the crane, transformer stations, etc. pp. This picture here shows the excavation and construction of the foundation of a transformer station. The next one is road construction. Yeah, please, next, Antje. Yeah, civil engineers are needed in a lot of the cases here. The first thing we always have to do is site surveying and the staking out of the positions of fence, roads, support construction, cable pathways, etc. The mounting structure must be installed. That's mostly mechanical work, and a little bit of structural knowledge does not make any effort. So it's good to understand that most of the modern installation systems are coming with a very nice and comfortable mounting manual. So if you follow that, you're on the safe side. Module mounting, combiner boxes, there's a lot of mechanical work included. If the mechanical work is completed, then the electricians come into the game. They have to connect all. Then in the utility scale systems, we have always a monitoring system and the grid communication systems, because our grid providers need to know which plant is producing what amount of energy, and sometimes they have to control it and to manipulate it. Grid connection is in our region a very important point. Planning And paperwork grid connection may last up to a year, maybe some years. It's really complicated, and I can imagine that with ESCOM is not less complicated. Okay, thanks. Next. Yeah, it's just an example how we do the site setup. You need a lot of installations before you can start with work. Even in Germany, we got an extensive health and safety law. That means we have to provide cabins for all the workers, toilets, storage places, working places for pre-assembling things, and parkings, whatever, what you need to work with 50 to 150 workers. So the size of this depends always on the size of the plant. Next, please. Yeah, this is just an example how they do the work. The first is surveying, as I said. Then if the rows are surveyed, they distribute the material, and then they start the ramming. Then they start with the installation of the support construction. Next, please. Yeah, just some examples of the cabling works. We have to do a lot of trenching. Here you see that's a quite wet ground. We face this problem mainly in the UK and Ireland. Germany is less or more okay. The next picture is a connection of the medium voltage or low voltage into the transformer station, to the inverter. Next, please. Module installation, a very important part of the game. We have to do that quite carefully with a lot of supervision, because modules are sometimes damaged during installation, and then you face a lot of problems during the regular operation. Thanks, Antje.
Yeah,
thank
you.
I can show you some pictures of my actual project. Maybe I share my computer. Just a quick thing. Normally I do all 2 or 3 days an aerial picture from the sites. Can you see that? Start from the beginning. Okay, I just go quickly through just to have an impression what we are doing. We started mid of March. This was the beginning. German spring, wet and rainy. Here you see the road construction. That's always the first thing what we are doing after surveying. More road construction. Then you see here in the center the first deliveries of the mounting system. The road system is growing. Just an example, this is a 260 megawatt plant. The road length is 8.5 kilometers. So just an overview. So you see that here, the ramming has been started and the construction of the support construction. Trenching as well. You see here's the trenches for the DC main cables. More materials are coming, then the construction is growing. This is just always the same. Construction is growing. And we have the first modules here. And you see normally a daily success or daily progress, what's going on. Modules for trenching. We have going to be constructing in this site for roughly 4 months. And we are planning to finish this site end of the year. So that means we are doing 260 megawatts now in 1 year with 100 to 130 workers. Are constantly on site. Okay, we are finishing now. I think that's the last picture from yesterday. So don't be astonished about the module distribution. We have different module types. One field is with different power class. That's why we are working in 3 different positions for the modules. Okay, that's as a small impression of what we're doing. Thanks.
Thank you, Antje and Dr. Klaus, for the presentation. Gives us quite a good overview of what we can expect when it comes to solar. So nice introduction as well in terms of what is going on within the country, the different potential that we have, and as you can see, so a lot of potential in the Northern Cape that we still need to address. So thank you for that. And I think then what we'll start doing is that we can start pulling in our panelists just to start a conversation and discussion. So colleagues online, if you have any comments or questions, just drop them into the chat box. Because I see now our colleague from the Mechanical Engineering Institute is not here, but we do have Professor de Kock. So Professor de Kock, I think let me call you in. If you can just introduce yourself in terms of who you are, what do you do for SAI, and maybe just from your side, just to get some views and comments in terms of the presentation that was just given now by Dr. Klaus and Antje.
Thank you very much, Chair. Yes, my name is Jan de Kock. I am the immediate past president of the Institute of Electrical Engineers. My term as president ended in March this year. Furthermore, I teach electrical engineering at Northwest University, and I'm a consultant as well. So we're quite a different number of hats. In terms of what has been said, I think let's first of all talk about what was not said. All the projects so far have focused just on PV, but there is also a second technology using the sun as an energy source, and that is concentrated solar power, where you harness the energy of the sun and capture it in molten salt. And in projects like that, there's a lot more civil engineering to be done because there's a lot more heavy engineering involved. So there are a lot more plinths and structures that need to go up. There are essentially two types. One has a tower, so you can imagine if you have to build a tower that is 100 or 150 meters high, there's a lot of civil engineering involved in that. And the other technology is with parabolic mirrors. It's fairly similar to PV panel installations where you have frames that carry the mirrors. So the structural work is very similar in that sense. If we look at PV from a technology point of view, I think one of the biggest drawbacks that we have with PV is the fact that the energy availability factor, something that Eskom is constantly measured about, is only 23% if you look at PV. Whereas if you look at concentrated solar power, it goes up to about 60% if you have sufficient storage. People always only think about the positive impacts that PV has on our grid and on our environment, but there are also a number of negatives that we need to consider. And I'll quickly run through a few of those. First of all, if you think of all the inverters involved in PV plants, they all produce harmonics. Harmonics effectively pollute your electrical power system. Then probably the biggest challenge with photovoltaics is the fact that they have a variable output. So, and they produce the most energy when we least need the energy that is being produced. So you need to couple that to storage. And that also has a major effect on the cost of installations. And now I'm talking about industrial size or commercial installations where you have where it's primarily a power plant. In South Africa, Antje said that the best place to put up PV is in the Northern Cape, and I fully agree with that. The problem at the moment is that we have a grid constraint in that we can't evacuate the power from the Northern Cape. It's like having a road system and the roads are too congested and the traffic flow decreases significantly. So we need to build more power lines. The challenge put to Eskom is they need to build 1,400 kilometers of power lines per annum for the next 20 years. So there's a lot of civil engineering that needs to go into that. And then the other negatives about PV is the fact that they don't have rotating machines, so the systems have low inertia and they make no contribution to system fault level. So in the Northern Cape, the system fault level is very low. On the other hand, if you were to look at concentrated solar power, many of those negatives are actually turned into positives when you consider concentrated solar power. We are also moving towards smart cities as cities develop. And here we can't just use PV, we need to also add storage to the energy mix so that we can use the energy when it's most needed, typically early in the morning or this time of the day. And for that, we then need to integrate not only PV, but storage as well into our power, into our grids. Storage has the advantage as well that you can get rid of some of the constraints if there are constraints in the system by adding local storage to a network. Both of the previous speakers have extensively spoken about the construction part of projects. And in South Africa, as is with the rest of the world, the focus is very much on low-cost installations. And here there is also a risk for all engineers, because as you cut costs, what are you saving on? Primarily on time. That means that less and less engineering is actually done, which is probably one of the biggest challenges we as engineers have within these projects, is they tend to become recipes rather than focus on real engineering. And then lastly, I think we need to also focus on policy and regulative frameworks. And as Antje has said, there's been very low registration of residential PV installations in South Africa. Cape Town has probably got the most. But that also produces a number of challenges, as that can have very negative effects if it's uncontrolled in residential areas. You can have excessively high voltages in the middle of the day, and you can have too high harmonics in the system, also either early in the morning or the middle of the day. And we don't know how the systems are going to react, because they were designed for power flow from the grid to houses, and now we're turning the power flow around with the amount of PV that we're actually installing. So what influence can we have on the installation of PV systems? Well, I think one of the most important things is we need to actually beef up our regulations, and more importantly, we also need to look at the enforcement of regulations. Otherwise, people and property will be damaged in the process. I hope I've answered some of your questions and some of the questions in the chat as well.
Okay. No, thank you, Prof. I think it was quite, also, an eye-opener, I think what's also nice one needs to appreciate is that when it comes to this type of installation, and I think not only for this infrastructure, but any other innovative new infrastructure, you need to consider a wide range of engineering skills. So in this case, obviously, you've mentioned, from the electrical side. Sorry, it's my energy saving in the building. Yeah, okay. I would look things like harmonics and feedback into the grid, and you spoke about now polluting with harmonics. So for those who are obviously not familiar, especially as a civil engineer, we don't know what you're talking about. But I mean, what it highlights is that it's important that even as if I just include myself as civil engineers, that you need to also educate yourself in terms of what is this, because so that when you look at this type of infrastructure installation, then you at least have an understanding and hopefully come up with a better design in terms of planning and developing. So maybe just for the benefits of some of the civil engineers, just maybe a quick explanation of what is harmonics and what do you mean by polluting with harmonics, just so that there is a bit of context and understanding from that point of view as well.
Okay, let me quickly explain what harmonics are. And let me use the analogy from the world of music. So how do you differentiate when you hear a violin and a guitar? Both are string instruments.
Yeah.
The differentiation comes in how warm the sound is, and that warmth is produced by the harmonics. In other words, it's frequencies that are multiples of the base frequency.
Yeah.
So in the case of power systems, typically you'll find if you have inverters, you have harmonics that are 5 and 7 times the base frequency of the system that we have in South Africa, 50 hertz. In other words, we're looking at 250 hertz, 350 hertz, and even at very high harmonics up to the 60th when you get to about 3 kilohertz. And this is typically the frequency where the inverter will take the DC, chop it, and convert it into AC. So you'll get a 50 hertz component, but on top of that, there's effectively noise.
Yeah.
That's probably the best way of describing harmonics as a pollutant is like noise. So one needs to get rid of this noise in the system, and for that you need to install filters.
Yeah.
That is an expensive piece of kit to install, and that challenges the financial viability of projects as soon as you need to start putting in filters to get rid of all noise.
And I'm sure even the maintenance of filters probably is quite an expensive exercise as well.
Not really, no. They're pretty much maintenance free because they don't have a lot of rotating equipment. There's actually very little rotating equipment, so all static.
Okay. So, but obviously then the installation cost is probably where the big cost, your capital cost upfront.
Upfront capital cost is where the problem is.
Yeah. No, thank you for that, Prof. And I think let me just go back to maybe Dr. Klaus or Antje. I don't know if you want to comment or give feedback in terms of the points raised by Prof. de Kock.
Yes.
Okay, Matthias first.
Okay.
The question is the following. I give you an image. I'm sitting in my cabinet on the side. So the costs for PV installations are quite decreased in the last 20 years. So we are constructing now for roughly 650 euros a kilowatt peak, these utility scale sites. So this attracts a lot of investors worldwide. What we are doing here is not a private business. These are commercial investors who are investing in energy production. This is not a game here. We are producing, let's say, finally for 2.5 cents a kilowatt hour in these sites, even in Germany. And related to the topic of storage, there is a lot of development in the last 5 10 to 5 years, we installed as well utility scale storage systems, these so-called BESS, battery energy storage systems, which are coming in containers, which are less or more usable. Now, this is a good solution to buffer this production. This is one version we can distribute our energy production regarding to the consumption. And the other point is you can do some constructional things like an east-west system to flatten the production curve. This is always a possibility. Then I think the energy storage problem will be solved within the next 10 to 15 years. This shouldn't be a problem, as a lot of guys are investigating right now. A lot of commercial utilities. I know that Rolls-Royce bought a small company developing BESS systems. So far, I'm quite optimistic that even with solar power, we can recover our nights.
Yeah, just if I can maybe touch on that, and thanks, Dr. Klaus. And I think the one thing that's coming out here now, maybe just follow through, is that with the storage now, it's becoming a big challenge now. And I think, especially when you have too much solar, what do you do with that extra solar? And then, as you can see, trying to push it back into the grid, Cape Town is allowing it. The other cities are not specifically allowing it. And what
No, they allow it. They allow it.
All of them or some of them?
Most of them actually allow it. So the only problem, I mean, Salga developed concepts for all the municipalities. So they developed a whole package for them, actually, based on what was done in the city of Cape Town. And there is, I don't have them now in front of my eyes, but so it's a lot of the cities, and all the big cities definitely allow it. The only problem is that, unfortunately, the team or the co-workers at the municipalities are not all as well trained as those in the Western Cape. And so the problem is actually as often the implementation, but
so
it
it's more
is
technical,
allowed.
more technical training.
More technical training,
yeah.
And also what Matthias just said, I think with the batteries, we really benefit from the different developments in Europe and South Africa. So in Europe, electricity is super expensive, and therefore in the last 10 years, as Matthias just said, a lot of investment went in the whole battery technology. Because of us having that load shedding issue, so in the last 5 years, a lot of research and developments happened in the direction of that hybrid inverters. So that we just in the old days we needed a grid inverter and off-grid inverter. They had to speak together, and all was very difficult, complicated, and a lot of material. Now, so the whole hybrid inverter technology developed a lot, actually based on the problem we have in South Africa, which now also benefits the European market, because here the people also have more and more battery systems, or in Europe they have more and more battery systems. And now I forgot. I wanted to add another point, but we will come back to that for sure.
Yeah. And maybe I think maybe just a question. I'll ask a question, and I'll ask. Maybe we can start with Prof. de Kock and then Dr. Klaus. Seeing that now, obviously, one of the options what's been mentioned now, that's the challenge being the storage in terms of battery, and maybe still 10 to 15 years, as Dr. Klaus indicated, in terms of technology. But what about alternatives? And I know one other alternative that's coming up is hydrogen, and maybe not specifically in the residential context, but maybe a commercial context. The viability of considering hydrogen as a form of storage, so that obviously when the sun does not shine, you can feed that hydrogen back in through a fuel cell and then generate power from that point of view. So, Prof. de Kock, just your views and comments around that.
Yeah, I see Prof has dropped off. I'm not sure if he's having
I see that
connectivity issues, so you'll have to bet alone for now.
Okay, we'll have to try and pull him in when it comes to that. And I've been struggling from my side, as I also got kicked out and it came back in. But yeah, just that time of the day. Dr. Klaus, I don't know if yourself or Antje, you want to just take that question? We'll come back to Prof. de Kock.
We have some pilot projects here in Germany to using photovoltaic power for hydrogen production, but this is quite expensive, and I'm not sure if actually it's market ready. But anyway, I think there are a lot of possibilities, especially for South Africa, because your consumption peak is during the day, I think, or one of the peaks is during the day because of the aircons you're running. So we have a different problem. We have or we had problems with the grid stability as well, and now they're using PV plants for stabilizing by providing reactive power. So every photovoltaic power site has some. Let's start differently. You have to apply if you want to install a utility scale plant with a grid provider, and the grid provider is defining standards what you need. This includes power monitoring, so the grid provider has access to the plant. And if there is an overproduction in the grid, he is allowed to shrink down the production of a single site. So that's the standard, and I think that essentially for the grid stability in all countries, if the amount of PV plants is increasing.
Yeah.
Otherwise, you are getting in trouble.
Yeah. Or I guess maybe one other way to look at it is that you need to have a balance of different storage systems. Again, depending on the baseload you need to try and cater for. That takes you through it. So Prof, before you got kicked out and came back in, so the question was that when it comes to storage, discussion being that you've got battery technology, and but that can also be quite expensive, and quite a bit more research or development still needs to be done. One of the other options I know that is currently available and might be a bit expensive, but green hydrogen, converting the excess power to green hydrogen and then storing that on site and feeding that back in through a fuel cell to then generate electricity, especially during the night and whatnot. Just your views on that, or maybe from your side as SAI and as a specialist in this field, what options are currently in the market in terms of just that storage when you have that access power?
Thank you. Yes, I think people are now very much focused on batteries, and that I think is to some extent driven by the likes of Elon Musk.
Yeah.
On the other hand, there's a very robust technology around in the form of pump storage. If you compare pump storage to batteries,
Hi, Prof. I don't know if it's me. I think he looks like he's frozen again.
Yeah, we can't hear Tick here. So, Prof, if you are listening, maybe just go out and come back in again. It's obviously too much solar energy affecting your system.
Disharmonics.
Maybe the harmonics, yeah, probably. Antje, you're on mute. I don't know if you want to comment as well.
Yes, sorry, I want to come in. Actually, there's two things. So with the green hydrogen, so as I said, I'm right now in Berlin. I attended a workshop with different sectors of renewable energies yesterday, and I also spoke with the people from the hydrogen sector, and actually they focus in Germany. I mean, it's now all over the thing, but especially in South Africa, Namibia, Germany, and Chile. And but the German people from the hydrogen sector, so they actually see the whole steel production market. So wherever what they call gray hydrogen is already used, so this they see as the first choice market to replace it with green hydrogen. And we also discussed the topic, so now with the huge system which will be installed in Lüderitz in Namibia, and the idea to produce hydrogen or ammoniac, or how do we call that in English? So to transport it to Europe It's so I actually asked them, do you think that this will become a second desert tech? So when we had the idea to produce electricity for Europe in the north of Africa, he did not say no, but he also did not say yes. So yeah, so I think this is like, so we have to see, and we have to, I'm definitely with Prof de Kock, so that but batteries is not the only one solution. And it's good that now a lot of people look on green hydrogen, but I think we should look on ammonia, thank you, on all the different, in all the different directions.
Yeah. No, look, it's quite a big growing topic, because I know myself also quite involved in that ammonia and hydrogen research. So you probably see quite a few publications from my side, but no, it's a very interesting field. And I'm just thinking of something now, because I know if you look at now North Africa with the Sahara and the solar capabilities, and I saw one interesting diagram that showed an underwater cable running from Africa to Europe, and even one from the US to Europe, and I think it was called either it's not high voltage, but like something super higher than a high voltage.
That's the desert tech thing, but
it's the
will
viability
not
of
happen.
that. It seems quite extreme.
No, that was the planning. And I think it was like 15 years ago, 20 years ago when the whole thing started. But I think 10 years ago, more or less, it kind of started to die. That's not. I think, and this is also what we do. I mean, there's a lot of different technologies. So not only solar, but also in solar, you have different options. And this is what we also teach in our academies, and what also all our trainers are working in the field and in different countries. So there's the one in West Africa, so they are more in the mini grid sector, the ones in Africa in the off grid sector. I mean, you have, but what we all believe is that the best electricity is the one we do not need or we do not consume, and the second is the one we produce where we consume the electricity. And therefore, I mean that we do not have big feed-in tariffs. That's not the thing. Solar is so much cheaper than Eskom electricity, and we also energy management becomes more and more important. So it all over.
Just to touch on that comment you raised now in terms of use on site, so on site generation and use. I know as much as now the Northern Cape has got this great potential for solar generation, and as Prof. de Kock indicated early on, the problem and the challenge is that Eskom does not have a grid in that area to evacuate the power. But having said that, what you are seeing now on the green hydrogen side is that on-site use and of that power for hydrogen generation. So perhaps maybe more of a viable case for that point of view in terms of on-site generation, and then more than wheeling the power elsewhere. Because I think until such time that Eskom builds grid that side, it's going to have to be probably mainly for the generation of hydrogen, and maybe those companies that set it up might give some of the local community power from that point of view. And that's what I say. I don't know your views, Antje?
Yeah, well, 100%. I mean, so that's definitely an option. So, and this is also what we have to consider. So when we think about Africa and green hydrogen, and I mean, our grid in South Africa is aging, but a lot of countries, they never had a grid. So, and we have to find individual solution. I mean, the question is the Northern Cape close enough that we can continue to sell electricity to Namibia? So that could be another way. But
an option. Yeah. It's something you might have to think about. Okay, I see Prof. de Kock, you are back. I'm hoping you're back online.
Yes, can you hear me now?
Yes, we can hear you now. So we just we had that question around storage and technology around storage. If you want to just continue, I think you just mentioned something about pumped storage, and then we got cut off.
Yes, I think that is probably the technology that has been around the longest. It's a very stable technology, and you can store vast amounts of energy in the process. As I was indicated earlier, in order of 250 times more than you'd have with commercial battery storage systems. And it's also green because it's probably a lot greener than battery storage because you don't have batteries and the risks associated with batteries.
Yeah.
And it has lots of opportunities for civil engineers because you build big dams and tunnels.
Yeah. Yeah.
So from that point of view, yeah, it's really an excellent technology. It captures many of the negatives that you find with the other green technologies in the sense that it adds to grid stability, it adds to system inertia, it adds to fault levels, and it also adds to the transient response. Remember that power electronics can only or cannot be overloaded for long periods of time. So power electronics really have limited overload capacity, whereas if you look at generators, they can be overloaded far longer periods than you can have with power electronics.
Yeah.
So there are a lot of advantages. The real big advantage from batteries is its immediate response.
Yeah. Yeah.
Batteries can literally in milliseconds respond to challenges, whereas pump storage would take
You need to start it up a bit. Yeah.
2 minutes, depending on what change needs to happen.
Yeah.
Coming back to hydrogen, in the sense it's still a developing technology. It's not a mature technology.
Yeah.
And transport is a major issue. There are limits to how far you can actually transport hydrogen. And if you want to go further than that, you have to convert it to something like ammonia or something else. I don't think that's really an option in South Africa at the moment, because we don't have a hydrogen economy at the moment. So
it's still early days in essence.
So if we are producing hydrogen, what are we going to do with it other than export it? Locally, there is not a big demand for hydrogen at the moment. So we need to either create an economy for it, or we need to look at something alternative.
No, correct. No, definitely. I mean, that's something that still needs to be developed and mature further and whatnot. Okay, so Prof, I'm going to ask one last question from your side, then we can just quickly pop onto the chat and we'll pick up a few questions there for the panel. And hopefully by then we'll be maybe at the point where we can start tying up the session. So Prof, just within this field of solar, just new technologies. I think I'm more looking in terms of now smart technologies in terms of artificial intelligence, machine learning, digital twinning. Is there anything that maybe from your side as a professor that you're teaching in that respect, or anything in terms of research? So yeah, just from that point of view, what's the up and coming things within the solar industry in terms of that?
Well, I think the characterization of load and the stability of the system is areas that need to develop fairly rapidly. You can, with PV systems, have so-called virtual inertia, where it's not a rotating mass as such, but it's rather power that you are injecting into the grid very quickly. And in that area, there's a lot of work that still needs to be done. As with the whole grid control is still a massive challenge. Remember, we're looking at a grid that is now changing very rapidly. Previously, everybody was used to coal-fired power stations and slow changing loads. Now we have faster changing loads. We have generation that changes dramatically by the hour. So all of these things require different control strategies. And that is the area where things like AI can really play a role in predicting what the grid is going to do in the next few minutes, in the next hour or two.
Yeah, and then using that, then obviously you can try and eliminate any challenges, and perhaps collapsing the whole system. I take it.
Yeah, well, in South Africa, for example, we're still learning about the energy market, that's also something that hasn't been discussed today so far, but I think it's important. We're going to have an energy market that's going to rapidly develop, and there are a lot of technologies that can be used in that area as well.
No, thanks for that, Prof. Okay, so thank you for that, and I think let's quickly then jump on to the comments and questions, and I'm just going to maybe touch on the first few on the top. Time dependent, we might not go through all of them, and colleagues online, whatever we don't get through, we'll then jot down the comments and questions, and then we'll get our panel members just to give feedback, and that will circulate to you once all that feedback is together. So the first one here is from Vedant Jugov. What are the most in-demand skills, specific technical and soft skills for civil engineers looking to transition into the green solar industry? So Anja, I think let me hand over to you, because that speaks more to the skills. So if I'm a civil engineer and I'm interested in solar, what do I need to go? And is there a short course? Do I need to study something, certify, or just that's
Come
your
to the
field.
Green
So
Solar Academy.
yeah,
That's a question. I mean, so the solar market in Europe, the engineers in the solar market are mainly civil engineers. But of course, we need the electricians, as Matthias said earlier. So if you want to start in solar, so it depends on what is your pre-knowledge and where you want to start. So we have different courses. I definitely would suggest one of the short courses of one of the SAPVIA accredited training academies, so such as ours. And so like the basic course, what people who want to start in solar, so where they start with, so people with an engineering technician or like higher education background, so they usually come to the what we call Super Solar School. This course is accredited as a 5-day PV installer course. So where we start with the basics, we have 1-day installation, we have system design. If you already have a pre-knowledge, so then you even could come to the commercial designer course, where we go more in the design of systems. But I mean, so I copied the website in, and we also have suggestion ways what to do and when, but it's definitely, I mean, this is how most of the people started, with a short-term course, because there's and all our not all our courses, a lot of our courses come with CPT points, especially the ones which especially are the right ones for engineers.
Yeah. No, thanks for that, Anja. And so the next question I've got is from Dirk Kruger, and I think before I ask his question, I think what's important to note is that we are not only civil engineers in this call, and there's mechanical engineers and electrical engineers. We had reached out to the other industries as well. So this one is specifically, from what I can pick up, from a mechanical engineer. So maybe I'll ask Dr. Klaus if you could just answer this one. So how can mechanical engineers get work in the solar industry? And I think maybe to add on to that, seeing that we then today discussed on the role of civil engineers, if you could just maybe high level indicate the role of mechanical engineers in the solar industry, Dr. Klaus. Thank you.
Yes, we are not talking about rocket science. So what I'm doing is site management. Basically spoken, I'm the nurse for all. You must imagine we have a lot of subcontractors on site. One subcontractor may do the mechanical support construction. One subcontractor is doing electrical works like trenching and laying or putting down the cables and connecting the cables. From my view, or from my point of view, an engineer, any engineer, can work in solar industry. He must have an open eye, and he must know when he has to ask an expert. I don't know how's education in South Africa, but in Germany, the civil engineers, the normal one, which I am, are, let's say, generalists. We know a little bit from most of the things, but we are not specialists. So what I'm doing is I'm identifying a problem, and then I ask a specialist. That's my job. And I'm keeping the things together, because all the subcontractors are focused on only their job. So my job is to focus on the total thing. My aim is to get a working plant at the end, which is handed over to the client. with all the quality documentation and whatever belongs to it. So far, there are no restrictions to any engineer. So we have a lot of different engineers. We have even mechanical engineers here, electrical, not even engineers doing site management in Germany. It's just having an open eye.
Okay. So no, thanks for that, Dr. Klaus. And then I think what you indicated is that obviously working on the site, as much as you're managing everyone, you do have mechanical engineers that's coming in to do some work there. So I think then for our participant online, even within projects, there would be a role. And at the end of the day, there would be, I would also imagine, some sort of firefighting system to fight fires or cool the system. There could be something down that line for mechanical engineers, but definitely look, I think, from what is common across all the engineering disciplines is the whole project management aspect. So even from that aspect, I mean, one can easily go into the solar industry as well. Plus, I mean, like Antje indicated, there is a range of courses online that you can go and explore and have a look. I'm going to take one question, and I think this question comes from Dudley Garner, and it's maybe more for yourself, Antje, and Dr. Klaus. I think within the European space, I don't think too much of an issue in South Africa, but it says here that I am concerned about the land lost from agriculture to PV systems. Soon we may have electricity to cook with, but no food to cook. Is this a challenge for yourself in Europe, or do you feel you've got enough land? I guess just out of interest.
That's definitely a topic, but Matthias, maybe you're first.
Yes, it is a topic. There is a lot of, in some regions where the PV plant density is quite high, you feel some resistance of the inhabitants. But normally, yes, that's a problem, definitely. But this problem is mostly solved by giving the inhabitants, the close inhabitants, the neighbors, a share of the plant. Okay. And meanwhile, it's some sort of law in Germany or in Europe that they are collaborating.
And we actually have enough space. It's more like a felt problem. And there's a lot of studies around so that we have enough space to feed the world and to harvest solar electricity.
Yeah.
We have a lot of spaces like old landfill sites, old industrial areas. You can fill up with PV because these areas are wasted. Sometimes they are contaminated. Old airports, whatever. We are using a lot of old military airports which are now wasted for.
So you're reusing space that is currently not needed in essence. Yeah.
Yes. Right.
Okay. So to my panelists, I think that I'm going to give everyone, let's give it a minute, half a minute, just maybe some parting shots from your side. Any final message that you'd want to say to the audience as we leave? Let me start with Prof. De Kock. Just some closing comments from your side, Prof.
I think it's really an exciting industry to be in. It's really developing very rapidly, and there's a large variety of roles that engineers can actually play, from construction to project management to even continuous management of infrastructure and the maintenance that goes with it. So, I think there's really a lot of challenges and interesting things to do within the renewable energy space, not only in PV.
No, thanks, Prof. Antje, your closing comments?
Yes, I mean, actually, it is an exciting industry, and especially in South Africa. So I started in South Africa working in PV when the market just were at its beginning. So, and I was not part of that movement in Germany before. And it's so exciting to see how we grew in the last year, and especially the last 2 years. And now the next step from residential to commercial. And so there's it's very nice to see that we are not only number 10 with that small amount of gigawatt installed, but that we really can have as much installation as the Europeans. Yes.
Yeah. No, thanks. Dr. Klaus, your final comments?
It is an exciting business, and it's a good opportunity to fill up your future, because I think that's growing the next 20, 30 years worldwide.
Yeah.
And meanwhile, we have a lot of lack of engineers in Europe. So Europe, I think, same as in South Africa and America, they're lacking engineers doing this job.
Yeah.
So
No,
far,
look, it's a field
excellent.
that it's a growing field that has got a lot of potential in essence.
Yes, definitely.
That's it.
Yeah. No, so thank you. And I think just some final notes from my side. Oh, there goes my power. So you can see I'm also sustainable on my side. If I sit very still, then power goes off. So look, from my side, just some closing comments. I said from a civil engineer, or civil engineers are quite critical. I think not only civil engineers, but any engineer, mechanical, electrical, when it comes to this type of field, they're very important. Everyone plays a role. So again, maybe just to touch on the topic being civil engineering. So the civil engineer, when it comes to the planning of the site development, the structural engineering component, your stormwater management, building of roads, there's a lot of potential for civil engineers. As was indicated early on, SANS 1060 or 10116 has been developed for the solar industry. So do follow up on that. You've got your 10400 A that also regulates your solar installation. So okay, there's also what was indicated. Then it comes to the construction site, quite a lot of planning needs to happen. Where will you place your storage areas, your waste areas, the management of the construction site? Quite a lot of planning needs to go into that. Also, the training into the solar field is very important. I think it's to bring the industry, the professions, and society up to speed. So we need to focus on training. Solar cost is becoming competitive. It's going to become cheaper, and like any technology, things become cheaper over time. As you would know, when cell phones first came out, you had to go to the bank to get a loan to get a cell phone, and now you can buy a very cheap cell phone over the counter. It's things become cheaper over time. So again, loss of development, and in terms of storage, we spoke about pump storage, green hydrogen batteries as forms of storage. And again, so as we move towards the green solar industry, sustainability becomes very important. As I mentioned at the start of the session, we are experiencing some extreme weather events. We need to be responsible and play our part in sustaining the environment at the end of the day. We need to reduce the carbon footprint. So let's be responsible and sustainable on our side. One thing that I didn't specifically touch on, but I know there's a concept of polymath, and it's something I'd like to promote as well. Being a polymath, what does a polymath mean? And as you've seen now, famous polymaths of the past, like Leonardo da Vinci. He was an architect, a mechanical engineer, a sculptor, an artist. So what that means is that we shouldn't be boxed in by our own industry only. And as we saw now, yourself as a civil engineer, go and get involved in a bit of electrical engineering, go and get involved in a bit of mechanical engineering, look at things holistically, and then what you end up with, especially when you go into these unique fields like solar and other artificial intelligence type industries, you get a bigger picture approach. And so you need to be a generalist at the end of the day. And as you would know, a lot of people like to say that, jack of all trades, master of none, but everyone forgets to continue the statement, but better than a master of one. So again, what I'd like to promote is that, go out there and broaden your field of engineering. We have to these days. It's becoming increasingly difficult to try and stick to one field. You need to also broaden. But I mean, that's me. That's what I'd like to promote. Uncle Tom, we are 6 minutes over. I think let me hand over to you. That's it from my side. Thank you, everyone. If you're not a SAICI member yet and you want to join us, please do become a member. Yes, I need to earn my keep. I must promote SAICI at the end of the day. Thank you, Uncle Tom. Bye.
Yeah, no, Tekir and the team, Aniki and Matthias and Jan, thank you for joining us, and for
Thank you very much.
SAICI and SAMECI for contributing to the success of the event. For those of you who've now got into the swing of these things and you are putting them in your diary for the second Thursday, not Tuesday, as Tekir, as he said, has had a bad week, Thursday. Next one is on the 8th of August. And we're going back into the ocean and Tekir's home terrain. We're going to start looking at some of the technologies of managing various components on the back of the PIANC conference, which took place in Cape Town a little bit earlier this year. So until then, I did put into the chat the next SASE events that are coming up. We've got a PPP webinar, public-private partnership, next week, Tuesday. I think I've already got over 400 delegates signed up for that. So please join that if you are interested in public-private partnerships, which perhaps are the way to deliver infrastructure in the future. And then we've got our SOS, or Support Our Student webinar, which is open to everyone, on the Msikaba River Bridge, which is a cable-stayed bridge that's going over a 92-meter gorge in the new N2 route through the Transkei. We are busy planning a physical site visit to that site to add to our virtual site visit collection, and hopefully you can join us for that. Thanks to Keir and the team, and we will see you all next time, and otherwise do have an enjoyable evening. Take care.
No, thanks. And one more before everyone signs up,
Thanks.
if you can kindly complete the survey. So I'll put the link in the chat box. So thank you again to my panelists and presenters. Much appreciated. I enjoyed the discussion. And if I can make one request, Vedant, if you're still around, just hang tight. I just want to pick up something from you while everyone else signs up. Thank you. Thanks, colleagues. All the best. Bye.
Thank you.
Cheers.
Bye.
Bye-bye.
Bye, everyone.